Hello everyone, I'm Prasad and I hope you have gotten a good introduction to this tutorial and what's about to come. Shiraz talked about two-node networks and being able to transmit and receive messages and the role of medium access control when you have more than two nodes in the network. However, the networks considered up till now were all fully connected networks. What do we mean by that? By fully connected, we mean that all the nodes in the network have a direct communication link available to any other node in the network. Note that this may not be the case in reality. A network deployed may be fully connected. For this reason, it is essential that the communication links between the nodes are established via a relay node, which both nodes can talk to. This gives rise to the need for routing and multi-hop links. As you can see in this figure, a network is shown with various types of links. The links are in different medium and may have different physical requirements. A good network capability is to be able to send a message over different types of links over large distances using multi-hop routes, and routing capability helps us to do that. So here is a good example from a network of nodes that was deployed in Singapore waters a few years ago. This network consisted of 5 nodes, and you can see from the figure on the right side that not all links were good for communication. A thick orange line conveys that communication link was good, and a thinner line means that the communication on that link is poor. This network is taken from a paper cited here, and the numbers on this image on the right shows the packet error rates in both the directions on a link. So as you can see, it is very clear that in practice, there is a strong need for routing. In order to add routes to the nodes in the network, there are two usual approaches. One, in which the network manager adds static routes on nodes, which need to know their route to certain nodes. Second way is to run a routing algorithm, which can discover the routes dynamically in a network and update the routing information on all the nodes. For today, we will simulate a network which is not fully connected and for which we will need multi-hop links. We will add static routes and see if we can establish connectivity successfully. We will simulate a 5-node network as shown here in this figure. Note the links with green lines are the direct communication links that are available. Also, note that the nodes that are black in color are surface deployed and are accessible on surface, perhaps over a browser, whereas the nodes that are gray in color are bottom deployed and are not accessible. The only way of communicating with these nodes is acoustically. Also note that there is a sensor attached to node 2 in this network, and Chinmay will talk more in detail about how someone can get data from the sensor to a node that is connected over the internet. So do check that out. Okay, so now let us simulate this network first, and then let us take a look at what routes we will need to add. So for simulation, let me share you how to first start a simulation. For that, let me open a terminal and share it. So you can see that I am in the path where I have the unit -3.1.0 downloaded. So you can download the same folder from the code that we have provided in the resources link. So the link is actually available in the slides. So download that and go to this folder in your terminal. Once you are in the terminal at this location, just type bin/unit sim, and once you press enter, that should open simulator IDE. So I will share the IDE now for you to see. All right, so as you can see that IDE is, simulator IDE is opened in the browser, and I am currently looking at the file tutorial network part3.groovy under samples. So I would like to draw your attention to these 5 lines of code in this file. What we want to look at is how do we actually deploy nodes at certain locations and assign them addresses and configure them in a particular way. So you can see in this file So for example, we deployed a node 1. Here we call the name of the node to be a 1. The address of that node is also 1. So address is something using which the node is identified in a network. We also give a location for this node. So this node is at 0, 0, at 5 meters of depth. Similarly, we also deploy node 2 at about 1 kilometer from node 1. And this one is at which is 30 meters of depth. Similarly, we also deploy node 3 at these particular coordinates, node 4 at about 3 kilometers from node 1, and node 5 at about 4.5 kilometers from node 1. So these are the same coordinates that we actually showed you in the earlier in the slide, and this is how you deploy them in the network. So note that node 1 and node 4, as mentioned earlier, are both accessible over the surface, perhaps over a browser. So this field over here, which assigns a web interface, which just enables a web interface so that these nodes are actually accessible over web. Moreover, you can also see stack. So each node is configured differently. So this file basically defines how these nodes are configured when they start. And finally, we also have a field called shell, which is set to true in this case, and which just means that you are allowed to run shell commands on that node. So this will be useful just for demonstrating certain things in the network later. So, so that's about it for how we deploy the nodes in the network. Now let's look at running our simulation here and see the actual nodes. So I have run the simulation by clicking the play button here, and I can go to perhaps map here and first see whether our network is deployed. So yes, we can see 5 nodes, and they seem to be at the right locations, as we saw in the slides as well. So since we do not have a GPS origin in this case, this network node was actually deployed in a blue screen, but if you have a GPS origin, it will actually show you at the actual locations. The second thing that I would like to check is I would like to open, since we have access to node 1 and node 4, I would like to open the interface to node 1 and node 4. So here is node 1 and here is node 4. And the first thing that I would like to do now would be to check connectivity between the nodes. So we know that node 1 and node 2 were about 1 kilometer apart. So let's try checking the connectivity to node 2. So how do you check connectivity in, let's say, TCP/IP network? You use a command called ping, which sends some packets and then gets the responses back. So we also have similar kind of facility in Unitstack. So let's try and do that just to demonstrate how to check the connectivity. So let's try and ping node 2. So 2 is the address of node 2. So and that is why I am writing here ping node 2. So let's try that. So it got the response for the first packet that it transmitted. It got the response from the second packet. And it has now gotten the response for the third packet as well. So 3 packets were transmitted and 3 packets were received, and there was 0% packet loss. So we don't want to do this 3 times. So next time I will ping, I will just use perhaps 1 packet to ping. So let's do that. So let's ping node 3. I can specify how many packets I would like to use for the ping. So let's ping node 3 and see whether we have connectivity with ping 3. And it seems like we do have connectivity with ping 3. So what about node 4? Let's try node 4. And this is taking longer than usual. And it does seem like we do not have connectivity with node 4. And eventually we don't get a response and we get a timeout, and we can see that there was 100% packet loss. So we do see that the connectivity to node 4 is not available. But let's check something. Let's check if we have connectivity to node 4 from node 3. Because in that case, I will be able to add a route via node 3. So I'm on node 4 and I would like to check if I can ping node 3. So let's do that. And yes, I mean, I can clearly see the response here, and it seems like the link between node 3 and node 4 has good communication. So next, let me go back to the slides. So now we have a 5-node network such as this deployed in the simulator. And we checked that there is no direct communication link between node 1 and node 4. Similarly, there is no communication link between node 1 and node 5 either. Although both node 1 and node 4 are accessible to us, the user over a browser, let us demonstrate adding an acoustic route for this link first. This exercise will help us when we add a route with more number of hops. So as you can see in this figure, both node 1 and node 4 can talk to node 3, and therefore we can let node 3 act as a router. This may be achieved in different ways depending on what framework one is using. In Unit Stack, there exists a routing agent which will forward the received packet to the correct destination node if a route exists. So let's do that next in the demo. So I will share the screen again. Okay, so there you go. So we have node 1 and we have node 4, right? So on node 1, first let's look at what are the routes do we have. It mentions that there are actually no routes that are available. So I'll clear the screen for a bit of clarity. Now let's add route. I would like to add route to node 4 via node 3 because we know that 3 has connectivity with node 4. So let's add that. And once we add that, let's check if the routing table is populated with this particular route. And yes, so routes does say that to node 4, there is a route and the next hop for that is node 3. It also mentions what kind of link you can use. So ideally, you can actually mention whichever, what type of link as well. So it could be an acoustic link, it could have been an optical link, it could have been an RF link or any other. So now we have added a route on node 1 to node 4 via node 3. Let's do the same on node 4 as well. So I would like to add route to node 1 via node 3. So let's check routes again, and we see that the route is indeed added. So why did we add route on both the nodes? Why couldn't have we just added the route on this one. The reason is because we also want to get the response from node 4. So we need a route to be known at both node 1 and node 4 to be via node 3. So now that we have added routes, let's try and ping node 4 again. And this time, let's again try for just one packet. It may take a longer time, yeah. And as we see that it took a little longer time than usual, but we actually got the response from node 4. And similarly, you could also try pinging node 1. I would like to just do ones from node 4, and that should also work. In fact, if you would like to look in the map, you can actually see that transmissions and receptions are happening between node 1 and node 4 and via node 3. Although node 3 doesn't have the web interface, so it doesn't show the visualization, but that's going through node 3. To confirm that it's actually going through node 3, what we can do is we can use this command called trace and to for. And what this will do is this will tell what route the packet takes when it is sent to node 4. And let's wait for a while it transmits the packet and gets back. And as you can see that the packet originated at 1, went to node 3, to node 4, and came back via node 3. So once we have added the route, we have checked the connectivities. We can also see if we can actually transmit some useful data. So we are on node 1. So let's say we transmit hello text to node 4. Let's try and do that. And we should get hello here since now we have a route. So if we didn't have a direct connectivity between node 1 and node 4, we established connectivity between node 1 and node 4 by adding routes. And then we transmitted the data and also checked connectivity. So what else can we do? Although note that here both node 1 and node 4 were accessible over web. In practical cases, there is a very high possibility that you actually do not have access to such nodes. So those cases are more interesting, where you have to add routes remotely, perhaps. And let's take a look at that next. So let me share the slides again. Okay, so we established a route between node 1 and node 4 using 2 hops. Next, let us try and do something more practical, as I mentioned. In reality, some of these nodes are not accessible for us to easily add routes. So for example, let's say I would like to establish connectivity between node 1 and node 5. We know that node 1 can talk to node 4 now via node 3. However, node 3 cannot talk to node 5. So we need to add a route on node 3 to node 5 via node 4. But how do we add route in node 3 if it is already deployed? This is very common scenario that occurs in practice, that you have already deployed a node that you do not have access to from surface, but you would like to change some configuration. If you are using a TCP/IP network application such as SSH, help us remotely access a machine. Similarly, can we access node 3 remotely from node 4 and add route to it acoustically? The answer is yes, we can do that. So we will add routes remotely on both node 3 and node 5 and establish connectivity between node 1 and node 5 next. So let's go back to the next demo. And let me share the simulator IDE again. So I'll clear the screen on both node 1 and node 4. So note now that node 1 has a route to node 4, although we would like to establish a route from node 1 to node 5. Although it has to go through node 3 because node 3 is the first relay that we have to go through node 4, and node 4 can act as another relay to node 5. And that is why what we need to do is we need to add a route on node 3, which basically gets the connectivity all the way to node 5. So let's add route on node 3 first. But how do I add route on node 3? So I know that node 3 has connectivity with node 4. So all I can do is a command which I can use for remotely executing shell commands on remote nodes. So what this does is this sends acoustic commands and it instructs to run certain commands on the shell of the other node. So for example, I can try RSH node 3, which says to run this particular command, which is add route to node 5 via node 4. So all it does is this command instructs node 3 to execute this command on its shell. So node 3, at the end of it, node 3 will add a route to node 5 via node 4, and this is what we need. So we run that, and it will send all the acoustic packets in water. It will basically execute this command, and at the end of it, it should have added a route on node 3. So let's check if it has indeed added the route. So to check that, what we can do is we can say RSH3, and let's check the routes on node 3. So this command executes routes command on node 3's shell and returns the result in this to this node 4. So ideally, after running the above command, it should have added routes. And as you can see here, after a while, it should actually show the route that has been added here. And yes, as you can see, the route is added successfully. At the same time, you also need to add route on node 5 because you want to do two-way communication. And that is why now it should be similar to what we did earlier. So it should be add route to node 3 via node 4, and that should do the job. Once we add that, we can also check whether the route actually got updated on node 5. So let's do that next. So we can say run this command, which runs routes and returns the output of it acoustically to node 4. So we run that, and this should send the packets, and eventually it should get back the routes. So now we have established connectivity between node 3 and node 5, but we cannot check whether this connectivity actually works because we do not have access to both node 3 and node 5, but that's not a problem. What we want to establish is a connectivity between node 1 and node 4. So we have added route on node routes on node 3 and node 5, but now we need to add routes on node 1 to node 5 as well. So what we need to do is we have to add a route to node 5, and the next hop for this should be 3. So now if you look at routes, it should give you two routes, the one which we added earlier and the one which we added now. Similarly, what we need to add on node 5 is again route to node 1, and that should be 1, and the next hop should be 4. And once we do that, we should be able to see that the routes should be populated. So this one should have 2 routes now. Yeah. So now we have added both the routes, and we have, so on node 1, we have a route to node 5, as well as on node 5, we have a route to node 1. So now let's try and do a ping to node 5 in this case. And I would like to just transmit one packet. This may take a few seconds for it to transmit the packet via 2 relays and then get the response back. So let's wait for that. And as you can see that it took about 17 seconds, but it got the transmitted one packet and it received one packet in those 17 seconds. And there was 0% packet loss. So this is how we establish routes in a network which is not fully connected. So we looked at an example of adding a route where you just had 2 hops or 1 relay. And we also looked at an example of adding routes where you had 2 relays and we had 3 hops. So both the cases are very useful. So now let's get back to the presentation and see what's next. So great. So I hope that you have learned something about routing in networks that are not fully connected. I would highly recommend you to spend time and work out the demonstrations that we did by yourself. Utilize the code and resources available at the link below and ask us any questions in the chat. Also coming next is an interesting session on the sensors and the internet by Chinmay, where you will learn about how the data from the sensors underwater can be delivered to a node on the internet using underwater networks. Do check that out. Thank you and see you again.